Hi all, suppose I want to write one program in which I want to add two integers, say a and b are the integers. So for a and b I will take the value from the user, say printf, enter two integers, scanf %d twice, comma ampersand a, comma ampersand b. And I will call function which is add function, which will add two integer values. Now a and b are local variables of the main function. So if I write some function add that is not knowing the values of a and b, so I need to pass values of a and b from main function to add function. So for that I need to mention a comma b here. Now these are called as arguments or parameters to the add function, or specifically they are called as actual arguments or actual parameters. So here a and b are actual arguments or parameters. Now this is function call. A and b are passed to add function by value. Now I am passing the values of a and b to the add function. So this method of calling function is called as call by value. Now there are two methods in C language, one is call by value and other method is call by address. When I pass a value of the variable to function, then it is call by value method. If I pass address of the variable to the function, then that will be call by address method. So right now we are looking into only call by value. So I will receive a and b here. So here first I will write the data type of the variable. So a is integer, so int. Then I will say a comma int b. Here a and b are called as formal arguments. Or parameters. Now in the definition I will add a and b into some C variable, and I will write one more statement which is return C. So now this statement is return statement. Now if you observe this function, here the return type is not void as we have seen in the earlier video. We have implemented one display function and return type was void. Now this is a function with some integer return type. That means this particular function should return some integer value which is nothing but addition of two numbers. So I am returning C. This statement we have to write if we are returning something. Now where this return value will go? This return value will go at the place of function call, so it will come over here. Now I want to print the addition. So before I print that, the return value I have to collect in some variable, say C here, equals to, and after that I will say printf addition is %d comma C. Now let me compile and run. Name of the file is functions.c. So gcc functions.c -o, say add, it's name of the executable. Error is C undeclared. In main function also I have to declare C variable comma C /add to run. Enter two integers 12, 24. It is printing the addition which is 36. So this is how you will implement a function using call by value. So this is the function call by value. This is the function definition. A and b in the main function they are called as actual arguments, and here they are called as formal arguments. Now I have used the same names. The same variables I am using in both the functions. Main is also having abc and this add function is also having abc, but those variables are actually allocating different memory. So there is a separate memory location for a of main function and a of add function, separate memory location for b of main function and b of add function. So there are separate copies. Not necessary that you will always take the same names, you can change the names over here. Here I can say p, q, r, and I will write r equals to p plus q. So this is okay. So names of the actual arguments and formal arguments can be same or they can be different. Still it will run. If the function definition is lateral to the function call, that means if I write the definition here, then I need to provide a function declaration. So declaration means I will write return type, name of the function, and data type of the parameters. So int comma int. So this is how we will implement the add function by value. So please like the video and subscribe to my channel. I will see you in the next video.